So today we're making a foldable on the properties for algebra. So some of these properties you've hopefully seen before and some of them may be new. So first thing we're going to do is you're going to take your foldable and you're actually going to flip it over and you're going to fold it like a hamburger fold. Okay, so folding it in half, and we'll make our crease there. Okay, and the reason that we're doing that is so that when we open it up, we see that there's a center line. And you can trace that center line if you want. I'm going to go ahead and trace it. If you don't want to trace it, you don't have to. But this is just to show the center of our foldable. Okay, next thing we're going to do is we're going to take the left side and we're going to fold that to the center. And then we'll do the same thing with the right side. We'll take that and fold it to the center. Awesome. So we should be able to see all of our properties: commutative, reflexive, associative, symmetric, and so on. Now notice we have these little dashed lines. We're going to cut along those lines. So if I'm cutting right here at commutative property, I'm only going to cut until I reach that first fold right there, so that we have a tab that'll open up like that. So we can go ahead and cut those. And so you can pause and cut out those tabs and then check back to make sure that you did it right. So if you cut along the dashed lines correctly, your foldable should look something like this, where you can open up each individual flap and close them so that you can see the properties. Now, along with our foldable, you also have this half sheet with a bunch of different examples on it. And if you count, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12. Let's go ahead and cut out the 12 boxes. Awesome, so we should have 12 little squares now, and they're all giving examples of these properties. So what we'll do is we'll go through, we'll define the properties, and then we'll find the square that matches them. Now some of these properties you should recognize, like first of all the commutative property. So I'm going to take some notes on this and make sure that you take notes as well on your foldable. So one thing that I like to recognize immediately with the commutative property are the first two letters CO. And I recognize these because they help remind me that commutative property means to change order. Okay. And let's go ahead and open up that tab. So we can write the definition on the left side right here. And we'll say that the commutative property says we can change the order. I'll zoom in here. We can change the order of the terms we are adding or multiplying and the sum, or if we're multiplying the product, stays the same. Okay. We can change the order of the terms we're adding or multiplying, and the sum or the product stays the same. So we're either adding or multiplying, we're not subtracting or dividing anything. So now what we're going to do is you're going to look through all of these examples and you're going to see which one of these actually represents the commutative property, which is showing the fact that we can change the order of what we're adding or multiplying and it stays the same. All right, so hopefully you found that this represents the commutative property. We're changing the order x plus y, it's the same as y plus x. Or x times y is the same as y times x. So we can go ahead and glue that into our foldable. Now let's move on to the associative property. Hopefully we remember when we talk about the associative property, something that we should be looking for is parentheses. Now it doesn't mean that everything with parentheses is always the associative property, but in order for it to be associative, it has to have parentheses. And it just says this. The associative property says that the sum or product, so we're talking about addition or multiplication, is the same regardless of the grouping. And by grouping, we're talking about parentheses. We group terms using parentheses. The sum, so addition or product multiplication, is the same regardless of that. So let's go ahead, look in here, find which represents associative. All right, hopefully you found that this is it. So notice the order of the items doesn't matter. I have x plus y plus z is the same as x plus y plus z. So the order is staying exactly the same. X comes first, then y, and then z is the last one. The only thing that's changing is the grouping. So notice in the first example, y and z were grouped together, so these two. And in the second example, x and y are grouped together. So the grouping changes, not the order. In this case, the order, we're going to add this, order stays the same. Order stays the same. Okay. All right, how about the identity property? So there's identity of addition and multiplication. So again, we're going to talk about sum or product. So we'll say the sum or product keeps its original number the same. The sum or product keeps its original number the same. So identity, we should think I am myself, I'm staying the same, identity. So look through and see if you can find which of these examples shows the identity property. So identity is found by either adding 0 to a number or multiplying it by 1. Notice in each case, if we start with x, x plus 0 keeps it x, x times 1 keeps it x. That's identity of addition and multiplication. For the inverse property, we should automatically be thinking of the word opposite. And opposite's going to mean a couple different things when it comes to addition and multiplication. So when we have inverse, we can say the sum slash product of a number and its opposite is, well, if it's a sum, it's going to be 0, and if it's a product, it's going to be 1. So the sum of a number and its opposite is 0. The product of a number and its opposite is 1. So let's find which one of those actually matches that. And in fact, it's going to be this one right here. So a number plus its opposite is going to give us 0. And a number times its opposite, or its reciprocal, is going to give us 1. So let's glue that in, and then we're going to add that keyword reciprocal, because that's a word that you're going to hear a lot. So anytime you have a number flipped like that, like 1 over x, that's called the reciprocal. Reciprocal. Zero product property. You remember what that means? It just means that anything times 0 is 0. So anything times 0 is 0. That could be a number, it could be a variable, it doesn't matter what it is. Anything times 0 is going to give us 0. So let's find the match for that. Here we go. It's always going to be 0. And now we have the distributive property. So we've kind of talked about this before. So remember the distributive property, we always have parentheses, and then there's a factor on the outside of it, so some number on the outside of it. So the distributive property is multiplying a sum or difference by a factor. Okay. So it could be addition on the inside of the parentheses, so these are in the parentheses, by a factor or the number on the outside. So let's find which of these matches the distributive property. And here we go. So that's going to match. So when we're distributing, we're saying that if I'm multiplying x times y plus z, then that's x times y plus x times z. So I'm multiplying it by each term on the inside. So x times y, and then x times z. So we'll add that. So far this has been a review of properties that we've already seen before, like inverse, identity, all that good stuff. So now we're getting into some new ones. So we're going to start with the first one, which is reflexive. All right, and reflexive property, I like to think of the word reflection, because when you look at your reflection, you see yourself. So reflection, I see myself. And the reflexive property says this. It says that a number or expression is equal to itself. So it's as simple as that. Just a number or expression is equal to itself. So take a look at your cards and see if you can figure out which of these represents the reflexive property. So we should find that x equals x and 6 equals 6. Simple as that. A number or an expression or a variable is equal to itself. X equals x, 6 equals 6. The symmetric property is a little bit different. So when you see symmetric, think of the word symmetry. Okay, symmetry. So symmetry means that if I have a picture and it's symmetric, I could cut it in half and the left side would look exactly like the right side. And it's kind of the same thing with the symmetric property of equality. So if something is symmetric, I'll just give you an example. If A equals 2, then 2 equals A. So we can switch the terms around the equals sign. So switch the terms around the equal sign. So let's see if we can find that example. And hopefully you found it. And it's more than just a single term. The example that we have actually has an expression. And it says, if x plus y equals z, then z equals x plus y. So we're going to switch those terms around. So we have x plus y on the left being equal to z. And then we're going to switch it and say, well, then z is equal to x plus y. And that is the symmetric property of equality. And we'll come back in the next video to finish up this, these notes.